Hello everyone and welcome to Deep Learning with Thomas. Today I will show you the gradient descent. First, you have to know what is a gradient descent. A gradient descent is just a derivation in a lot of dimension. I will give you an example. If you have a function with two parameters, x and y, which have this form, like this, and you want to make a derivation of this function. So derivation of this function can depend of two parameters, the x, and you can have the derivation with the y. When you make derivation with the x, you have to take the x, you derivate it, and other terms are considered like constants. So this one don't have any term here, so it will go out. This one have a y, so it will stay, and this one will have a basic derivation. I will show you. You have this x plus 5y, and the second you have 3x power 2 and 5. A gradient descent in deep learning, it's just for train the model, and we make a comparison between how much the output is wrong, and we calculate the error in every point. The goal is to minimize the error function. I will show you. Alors, so first you have I will draw the error rate. You are in a base like this, and you have your error rate. It's a function in here in 3 dimensions, so it's something like this. Here, just here you have 0, here you have 1. So here at 1 the error is maximum, and at 0 you have no error. It's the goal. Here in red you have a function. It's just a kind of paper, but the function could have could go in the 1, and other time this can go to the 0. Here, for example, you have 0.02, and here you have 0.8. So this function, you will start here with a big error rate, and your goal is to go in this point. This is the point with the lowest error rate. So we have a formula for this. It's it's a power n plus 1 equals a power n plus gamma and this. I will explain you. Don't be scared. Oh, it's the formula for the error function. If the how to explain that? If we are here, the error is maximum, and here the error is minimum. So the gradient descent is to descend the gradient here for going here. It's why it's a gradient. In the formula you have this. It's the point of a link. You have different link. I will show you how to go to reach the point. You start here, and the gradient show you the direction, and the scale explain you how much do you go out. For example, the gradient say, okay, the best way is in this direction, and the scale cell you can move, for example, for 0.002 dimension, 2 foot. So you can reach this point. After, the gradient say the same thing, like this, like this, like this. You will come here, and it continues to reach the point. There is different model. For example, if you put a large scale, the gradient say you can go in this direction, so it could be like something like this, and after it shows the direction, but it could be something like this and something like this, and the gradient can be lost, and you don't have the minimum of the error rate. So, and in the other time, if the scale is very small, like this, like this, like this, you have a very good information, but the train time is very long. So in the formula, you can see here the point of the link. So the link is here, for example, or here, or here. Gamma here is the learning factor or learning rate. If gamma is high, if the move we move a lot, and the scale is tall, and we oscillate a lot. But if it is small, we augment. The learning time is more important. And here you have the error. The gradient, the gradient make a calcul of the descent and show the direction, and the gamma presents the length of the scale. If we have a problem, we can do a backpropagation. A backpropagation is to come back on the different link in a lot of neurons to do a descent of gradient. It permits to go back to the source. For example, if you are here, you have a big error rate, you can go back here and start again to be here, here, or here, and to find the best way. So this process is called back propagation. It's very common in deep learning. But you see, with this model, there are three main limitations. I will explain you. First, inputs are all in the same length. For example, you can have a big input and a small input. You have the same, for example, for an image, you have the same image and you don't have other image. If you want image like this, you can do, sorry for the pink, you can do, you can grow pixels. You can do big pixels. The second problem is the complexity of the network. And the third problem is it's hard to modelize a temporal series. For example, it's hard to modelize a video or a traduction because the network don't remember what is before that.